when you're graphing a rational function, you got to find your asymptotes, right? So I wrote find the vertical asymptotes. We talked about that yesterday. That's hopefully what you did on your homework yesterday. Setting the denominator equal to 0. Find your horizontal asymptotes. You have to learn those rules before we have a test about the degree of the numerator and the degree of the denominator. And if you find your asymptotes, it kind of breaks your graph up. And there's definitely an easier one of these, like we're going to do on number 1, and then there's definitely a harder one on here. I think I only have 2 examples here, and then I have a worksheet for you with some graphs to practice graphing, because I keep telling you that you don't have to graph, but today you have to graph. All right, so for this first one here, I said sketch the graph of f of x equals 1 over 3 minus x. Find your asymptotes first. So my vertical asymptote, I just set the denominator equal to 0, and I just solved that. And you don't have to show me the work of how you get that. If you can just kind of do that in your head, that's okay. If you need to show the work that you're going to add the x over or subtract 3 and then divide by a negative, it doesn't matter. As long as you can solve that and tell me that you know x equals 3 is a vertical asymptote. Horizontal asymptote. There is no work to show. You just have to know those rules. Comparing the degree of the numerator, the degree of the denominator. So what would the horizontal asymptote for number 1 be there? There could be no asymptote. It could be y equals 0. Or it could be where you have to take leading coefficients, which means it could be any number. Those are your 3 options. What's this one going to be? The degree of the numerator, there's no x up there, so the numerator degree is 0. The denominator has an x, so the numerator is less than the denominator, which means it should be 0. All right, so you've got to know those rules. I'm going to cheat here a little bit and use a fancy little dotted line here. An asymptote is a line that your graph gets closer and closer to. So we tend to show that with dotted lines. So at x equals 3, so on the x-axis at 3, oh, I'm a little off. I'm going to make a dotted line. Cheating dotted line. And y equals 0 would just be the x-axis, which is also shown as a dotted line. I got to fix it because it's not. My cheating failed me. Right? If I was on my regular paper with a pencil, I would just kind of make a dotted line. I think it's helpful to put those asymptotes in there because, yes, dear. It's just x equals 3 because that's the only number, right? If we plug negative 3 in there, that doesn't equal 0, that equals 6. Yesterday we did one that had x squared in the bottom, right? So if it was x squared, you take the square root, that's where you get the plus or minus. Other questions on where those came from? I think the asymptotes are important to graph because now it breaks our graph up into pieces, and you should have, if you have one vertical asymptote, you're going to have a part of your graph on each side of that, and that's where it's the go-to, this is my rational dance move. That's what's going to happen, which means I don't pick a ton of points. You can pick a lot if you want. It's not that much fun to pick points on these. But that's where it's my third step. Plot points in each interval. Pick numbers on either side of your vertical asymptote. And for me, I usually pick them like right next to my vertical asymptote. Maybe pick 2 if you need to. But if I have an asymptote at 3, I'm going to pick 4. And if I plug 4 in there, 3 minus 4 is negative 1. I think I'm going to get negative 1. Everybody with me on where I got that? So if you find your asymptotes, you don't really have to pick any more points here. We could pick more if you want. We can see what's happening. But if you see your asymptotes kind of tell you where your graph's going to go. If you know that general shape, I know this side's going to go up and get closer and closer to that asymptote. And I know that means this side's going to go down, and it's going to get closer and closer to that asymptote. There's no other way I could draw it. It shouldn't cross the asymptote. Terrible line. It should be like smooth curve there. If you're not sure, you just pick more points. But that's really great. I'm only going to pick 1 on that side. Then I'm going to go to the other side, and I'm going to pick 2. Because 2 is right on the other side of that vertical asymptote. And if I do 3 minus 2 on the bottom, I just get 1 over 1. And again, the asymptotes tell me that this side's going to go up, and that side is going to go down. And mine kind of touched there, but let's just get closer and closer. If you picked a point, and maybe it was really far away, like way down here, maybe you should pick another one just to kind of see how fast it's going. But when it's right next to the asymptotes, like you know it has to follow that. So people freak out about these, but I think they're not that bad. Well, this one's not that bad. It gets uglier when there's more than one vertical asymptote. All right, so let's look at one of those, and then I'm going to give you 4 problems to do for homework. Questions on that? It's a Christmassy graph today. I'm trying to do. Okay. This one, 3 over x squared minus 4, kind of like the one that we did on the notes yesterday with the x squared. If we set this equal to 0, we are going to get 2 vertical asymptotes. Because I'm going to do the factor it, but I'm just going to add the 4 over and take the square root. And I'm going to have 2 vertical asymptotes, which means instead of just the 2 input parts, I'm going to have a middle section as well. And what would the horizontal asymptote be on this one? Also 0, because the numerator is less than the denominator. There's no x in the top, there's x in the bottom. You're always going to get y equals 0. So if I make my dotted lines here at, oh, that's not a straight line, y equals 0, and x equals negative 2 and positive 2, this is where you're going to have that middle section, and maybe you remember from doing these last year, the outside edges are still going to be that shape, right? Where normally it goes like this, but they could be both on the top or both on the bottom. But now you have this extra section in the middle, and that's the part that you have to just pick some points and see what's going to happen. I always do the outside sections first because I know they're those shapes. I call them L shapes. I don't know if they're really L's, but that's what I call them. So again, the asymptotes are super important. That's what I would be checking first. Are your asymptotes correct? Then I would check, do you have the parts of your graph right? So I'm going to start on either side of my vertical asymptote. So if I have a vertical asymptote at negative 2, guess what I'm going to pick? Negative 3. I always pick the number right next to it. Sometimes it works out nice. Sometimes it's not going to be so nice, but you can use a calculator. Remember, when you square that, that should be positive, though. I'm going to show my work here. That would be 3 over negative 3 squared is 9 minus 4, which would be 3/5. Agree with that? How do you graph 3/5? Just go less than 1, right? So at negative 3, it's not even quite to 1, so I'm just going to make a dot there, very tiny dot. And just like the last problem, I'm not going to pick any more points there because I know this side's going to go up and this side's going to go down, or follow the asymptote. I'm going to skip the middle part for a minute, and I'm going to go to this part, and since 2 was an asymptote, I'm going to pick 3. And this is where I just want to caution you. A lot of times they're opposite, right? Like one side goes like this, one side's up, which means you want to just put the other side down. But I don't think this is the case. Because of that x squared, when we plug 3 in there, we get exactly the same thing. Because it's squared, which means this is a rational function where they're both going this way, right? They're still that shape. They're just both on the top. They're both above the axis. for the horizontal asymptote. The middle part, I don't really have a shortcut for you. You have to pick some points. I will tell you, from what I know, the middle part is either always going to look like a parabola-ish kind of thing, or it's going to look like that cubic graph where it's kind of like an S. I almost call that S shape. I don't know that's that S either. But you're going to actually have to pick more than one point, because just picking one point isn't going to tell you. I also want to tell you that the fact that there's a horizontal asymptote, right? Vertical asymptotes, your graphs are never going to cross. Horizontal asymptotes are really about what happens as x is getting bigger and bigger and smaller, which means sometimes in the middle it will cross the horizontal asymptote, because it can be that value or cross that value. It just doesn't ever happen as it's getting further out, so people always get confused by that. I'm just going to pick some numbers here. I'm going to pick 0, and if I pick 0, I think I just get negative 3/4. Negative 3/4, something like right there. I'm probably going to pick both 1 and negative 1 to see what's happening. Make a new XY chart over here. Or maybe the fact that it's up x squared over there, you know what's going to happen here. If I plug 1 in there, what do I get? Negative 1, because I get 1 minus 4, which is negative 3, and 3 over negative 3 is negative 1. So at 1, I get negative 1. And since it's x squared, do I get the same thing when I plug negative 1 in? Yes? So I usually pick 3 points in the middle, because I'm trying to see, is it going to go down like this, which this one does, or sometimes it's going to go back up, and you're going to have like the I don't know that that's really an S, but I call it an S shape, or it goes like this. And yes, it can cross that line, that horizontal asymptote in the middle there. That's where these can get a little tedious, especially if there's like X's on the top too. That's where you're going to want to just use a calculator probably. But they're always going to be this general shape, and it's why knowing how to find asymptotes, I think, is like the most important part of these problems. Questions about that? Say that again? Oh, yeah. If the numerator is less than the denominator, and what I mean by that is the degree, right? So like the exponent, then it's y equals 0. If the numerator degree is bigger than the denominator, then there's none, no horizontal asymptote. And if the numerator is equal to the denominator, that's where you have to take those leading coefficients. And so we wrote it like y equals what? A to the n over b to the m. But that's where you take the leading coefficients. So there are 4 questions on here. All of them are rational functions. So the directions say find points of discontinuity, holes, vertical asymptotes, horizontal asymptotes, and graph. I really just want you to find the asymptotes and graph it. Like if there's an asymptote, a vertical asymptote, there is a point of discontinuity, but it's okay if you just don't have to write everything out. I want you to kind of do like what we did here. Number 1 is very similar to the one that we just did. You can factor the bottom first. But I do want to point out there's a negative sign in front of that fraction. It might be helpful to you if you just put that up there with the 4 and make that negative 4 on the top so you don't forget that negative sign out there. But on all of these, my advice, especially 1 and 2, factor that denominator to find your asymptotes, your vertical asymptotes, and then use your rule to find the horizontal. Some of these you're not going to get super pretty numbers, but you just graph the fraction the best you can. And I'm sure that we'll do like one of these on Monday together. We will turn this in on Monday. This is not on your assignment sheet, which means this is not due the day of the test. It's due Monday. All right, so make sure that you're attempting it. You're making an XY chart. Even if you do the math wrong, if I can see that you had your asymptotes right, and then you just plug some points in wrong, that's going to get you points, as opposed to just leaving it blank. And I'm sure we'll do one of these together. So make sure you know this is due on Monday. If you need some help on it, you're welcome to come in. And like I said, we'll do one of them together on there. But just factor, use your rules, make XY charts. A calculator is going to be really handy. If you don't have your own calculator, if you have a phone, you have a calculator on it. You can find free ones online. You have calculators available to you probably at some point during the day. If you're here and you have